Hello everyone, this is Bobby from Local TV Repair with another sharp aqueous video, this time for LC-52LE830U, which is giving us one long, one short blink. This is the one long, this is the one short. One long, one short. And this is what is it doing. Just giving one long, one short. There are different ways to approach that. One can go search for the service manual, find what does that mean, and there's nothing wrong with that. Another approach would be to just make the most out of the TV as it is, without need of service manual and without doubting what does it do. And earlier this week, I believe, or maybe the last one, I made another video of another power supply board. DPS, I don't remember the number on it. This one is DPS 143 BPA. Wouldn't be surprised if it was the same board. You know what? It looks a lot like the same board because I remembered. No, it was different one because that capacitor here for the PFC was, there was two of them. Here there's just one. But anyhow, in that other video I showed you how to test the power supply board to see whether it raises up by command of the main board. And this one apparently is generating the 5-volt standby in order for the blink code to be there. If you remember, if you know, all power supply boards generate one low power, low voltage for the sake of telling the main board, which is the computer, the brain of the TV, that, you know, it's online, and letting it stay online on monitor for a button press or for the remote. A very small portion of the power of the main board does that, just waking up for a wake-up call, and a very small portion of the power supply secures that. It's called standby voltage. And when the main board detects a reason to wake up and power the whole TV, it goes back to the TV and says, goes back to the power supply and says, wake up, we have work to do. And then the power supply board wakes up in several different stages, provides more juice to the main board, the rest of the main board wakes up, voltage is then sent again back to the power supply board to say, wake up, the final stage, the LEDs. This is how the LED is energized, this gets power, but it goes in stages. I'm not going to explain a lot of those right now. What I'm going to do is say the standby voltage on this board, just like with the one that I showed earlier this week, the other DPS, can be found on pin 15 of that connector, which is BU 5 volts. And the signal that tells from the main board back to the power supply to say we're about to wake up, start, do some work, is on pin 14, and it's called PS on, and it expects to receive 2.8 to 5 volts there in order for the power supply board to start waking up. Several things will happen, one of them being the power factor correction circuit, which I'm not going to get in details what does it do for. But one of the things that it does is it raises the voltage at which the rest of the power is operated from the rectified 160 volts to about 400 volts that you can measure on those capacitors that are in parallel here. So what needs to happen, and it's not the only thing, but what needs to happen when that power supply gets signal back from the main to wake up, is this voltage here has to raise from 160 to 400, 390, 380, 400. There may be a slight difference, but if it raises up and stays in one high value there, you know it is working. And because we've seen on the board that I did before that it wasn't doing that, and I showed you this little dongle that I made solely for the purpose of signaling those. You can do it with a wire, you can do it with a tweezers. Because this is a 2-row connector, it's not real easy. But the very first natural thing to do here is to do exactly that measurement. And as a first step, what I'm going to do is I'm going to get this on voltmeter DC and see what I have as of right now on those capacitors. I'm going to just touch. Plus and minus don't matter as long as I don't short it. Right now it has rectified 170 volts. So what I say is, if that power board works at a first step, it doesn't mean it works all the way up, because that voltage there can raise, but other things may not. When I tell it to wake up by emulating this main board, now it's disconnected, it has no brain, but it has my dongle inside, which tells it to wake up and generate 400 volts over here. And the question is, does it generate them or not? And the answer is no, it doesn't. It is told to wake up, and it doesn't. It is told to wake up because I have taken the pin number 14 and 15 as shown on the table up there, and I short them by simply feeding back 5 volts, and from my other videos it worked fine. What this tells me is that the power supply board is not okay, and the main board detects that because it probably does tell. Now there's a way we can plug that back in, and I can measure with a voltmeter when I press the power button whether it raises that PSON signal. It should be raising it, signaling the power supply board, and the power supply board just fails to activate for whatever reason. Seeing that the PFC is not starting up, that's another thing, that one of the first things that happen. In order for it to happen, that signal gets carried through one of those optocouples here, telling the small circuit on the primary side that 15 volts have to be transferred to power the little IC that drives that transistor, which in turn drives the power factor correction circuit. So something in that route is broken, and I will find out what and maybe make a second part of that video. But this is a simple way of knowing where the problem is, as opposed to looking at it. Doesn't guarantee that this is working good, but we know the problem is here. If I want to know that this is working somewhat well, what I need to do is I need to stick that somewhere in to ground and monitor that pin. PSON is pin 14, and the question is, which one is 14? Well, unfortunately 14 is the one that is on the inside. On the outside we are exposed the odd pins, 1st, 3rd, 5th, 7th, and so on. And to get to 22 I'll have to be using the sharp pin and testing that. It's possible, it's doable, but I don't know for how long it will raise it before it goes down, whether I will see it on time. What I do know for sure is that when I do it manually with my simple dongle, the power board doesn't raise up. So before I worry for the main board, I'm going to take out the power and see what I can do with it. I'll probably follow that with a second video.